So today we're going to talk about strong bases, and if you're not strong, then you must be weak. So strong bases deals with how well something dissociates. And there are only a few strong acids and a few strong bases, but everybody else is weak. So for example, this is a very common acid, hydrochloric acid. When it breaks apart, 100% of it dissociates into hydrogen ions and chlorine ions. Okay. If only, say, 80% of it dissociates, it's not strong. It'd be considered weak. So it has to dissociate completely to be considered a strong acid. Now, some of us think, oh, well, that acid, when somebody poured it on me, did a lot of damage. Okay, that could even be a weak acid that does that to you. Strength is dependent upon how well it dissociates. So really weak acids like vinegar, if it's a highly concentrated solution of vinegar, it could do some nasty things to you. But it's still a weak acid, and it only dissociates about 10 to 15%. But if the concentration of hydrogen ions are high enough, it's going to do some bad things to you. Okay. We will use this equation or expression here today. That's actually what our homework is going to be over, and I'll do some practice problems here in a little bit. This is an equilibrium constant for water. And we don't do a whole lot with equilibrium in here, but we do use this to help us determine whether something is acidic or basic, or on Thursday or later on to find out the pH of a substance or the pOH of a substance. So this is a constant, and this is a constant at a given temperature, 25 degrees, but this is pretty standard. Also, if you say that you have a higher hydrogen concentration than you do hydroxide, so if your hydrogen concentration is higher than your hydroxide, we're going to say that solution is acidic. Now, it doesn't have to burn you or do bad things to you, but it's on the acidic side of the scale. If we say that the hydroxide concentration is higher than the hydrogen, then it's basic. If they're equal, say the hydrogen is equal to the hydroxide, what can you say about that? It's what? So what can you say about that? If you have both together, it is not acidic or basic, but it's neutral. There you go. Okay, so when these concentrations are the same, we're neutral. We're not acidic and we're not basic. Okay, pretty cool. All right. Did all those things there. So far, so good. All right, and we'll do an example problem here in a moment using this equation. Weak acids and weak bases. Now, again, please, if you're planning on taking AP Chemistry, we'll probably spend a good 3 weeks talking about weak acids and weak bases. Today, we're not giving it the justice it so rightly deserves, but that's okay. It's okay. Okay. So, if it's not strong, then it must be weak. You like that? That's a good lecture. Okay. Let's do a practice problem. So what does it mean if it's weak in terms of...
It means they do not dissociate.
Does not dissociate.
To any great extent in water solution.
Or it's not 100%. Good. Okay. Oh, we don't want to do homework problems. What the heck was I about to do? Oh, that would have been tragic had I done that. Whew, that was a good save. Yeah. Okay. Ooh, that almost. Oh, all right. I was like, what am I looking at? That can't be right. All right. So here again, you will be given this, which is an expression for a constant. And the question says, calculate the hydroxide concentration if the hydrogen concentration is 7.45 times 10 to the negative 6. Then indicate if the solution is acidic or basic. So, we know the hydrogen concentration, and we're looking for the hydroxide. So that means that we need to divide the hydrogen on both sides. So if I were to rewrite this, I would say that I'm looking for the hydroxide. And I'm going to have my constant on top. And then I'm going to divide it by my hydrogen. my given. Okay, and it's a good idea to show that. That way, when you're comparing hydrogen to hydroxide, you're like, what was the hydrogen concentration? Well, if you just write it there, it makes it really nice and easy. And trust me, this is a lot of work when you actually think about it. And then plug in your value for your hydrogen. Now, this is the challenging part, making sure that you can actually get this value. Okay. So type that in on your calculators. Let's see what you get. Don't worry, we're not in any hurry. And if you get a negative 19 or a negative 21, you did it wrong. Come on now. I bet everybody got like 1.34 times 10 to the what? No. Now I want to make sure everybody can type this in. That's why I'm having you do it. Okay, so if you're getting something like this with a bunch of zeros and 1, if you have a TI, hit your second button, then I think it's DRG, and then there's an arrow button over on the side. Here, let's see. So there's like an arrow, hit this guy, and then you should get something like times 10 to the negative 9.
So do you want us to change the sign?
I mean, if you get a bunch of zeros, yes. Because if you had a whole bunch of zeros and then a 1, that's not the same thing as this. Okay, the way I would type this in. Okay. How do you type it in, Celeste? Do you do times 10 or do you use the E button? Okay, well, let's do that. So times 10, caret, negative 14, divided by, let me zap this guy, and do parentheses, so it's 7.45 times 10, caret, negative 6, close parentheses. Try that. Only one set of parentheses, right? Did you do negative 14 or positive 14? And what'd you get? Okay, good. So now you're going to do, press your second button, and DRG, and then you have your arrows hit this guy right here. It's on top, second DRG. And then you have your arrows, arrow to the right one. So it says psi, then hit enter. Yours, turn your face so I can see it. Hit mode, arrow down 1, arrow to the right 1. You are second DRG, arrow over 1. So at the top left, second DRG, arrow to the right, so you get side.
There we go.
Okay. Something like that, yeah. Ridiculous, okay? Oh. Yeah. All right, so to answer the question, is this acidic or basic? And how would you know? So let me ask you this. Is hydrogen hydroxide? So is the hydrogen greater or is the hydroxide greater? Which one is it? Which one is it? Which one? How do you know that? Good. So negative 6 is definitely a lot bigger than negative 9. So the hydrogen is greater than the hydroxide. So what kind of solution is this? Acidic. Very good. Try the next one on your own. Don't peek up here. Don't peek. I know it's tempting, but don't do it. Okay. Don't do it. Don't do it. Don't do it. Don't do it. All right. Down. Okay. So let's answer this. Does hydrogen have a higher concentration or hydroxide? Hydroxide? So everybody agree with that? Okay, so acidic or basic? You're going to say acidic? So which one's bigger, hydrogen or hydroxide? No guessing. That's a good question. Why would hydroxide be bigger? What's the number for hydroxide? Times -3. And this is 12. So which one's bigger, -12 or -3? There you go. So, since the hydroxide doesn't have as many zeros and, well, it's a smaller number. I'm sorry, bigger number, then that means that this solution is basic. Basic. Only so, that's not bad. All right, so the 3s are your homework.